Thank you so much, Nishta, and a very warm welcome to everyone. It's an exciting opportunity for us to present a different angle towards the work that we all do. Um, both Arnab sir as well as Commander Prashant sir before me aptly put how technological intervention is basically required for us to drive the startup ecosystem forward and for us to drive the innovation forward in terms of UDA. And today I'll be making a presentation representing one of the angle for the same, which is for the marine spatial planning. So before we understand what marine spatial planning really is, we need to understand what kind of existing problems are there today. Um, the if you look at the overall marine and coastal zones, there is an escalating pressure in the zones. There is an immediate expansion of urban ecosystem. There is an increased shipping. I mean, if we compare between what the Cold War era showcased and right now in 2025, we can see a tremendous exponential increase in the shipping noise, both in terms of the number of ships that are present, as well as the size of the ships and the amount of noise that they generate. While they definitely provide an extremely beneficial economical overturn, it also has a conflicting aspect of lack of endangering the marine species and the coastal ecosystem, and even for the livelihoods for the local fishermen and farmers present in the region. It is extremely difficult for them to make a livelihood. And therefore, it is important that we take into consideration those aspects and try to address them. And again, me being a computer science enthusiast, my lookout for the same has largely been from a technological aspect. And the problem goes beyond a lack of technological intervention. Again, as rightly put by speakers before me, it's also about the vulnerabilities in the sense of there is a very huge amount of lack of data sharing. No two stakeholders in the state are aware of what happens in each other's region. Everything is siloed. And this is not just something that we are making a statement of. World Bank has also added this in their report for the Indian subcontinent, that the governance remains to be fragmented. Therefore, what we end up with is an environmental degradation, economic loss, and heightened security vulnerabilities that we need to address. Now, before I move on, and we'll come back to this further down the presentation, there are two problems that I would like to showcase here as an example of how MSP, money special planning, helps. The first example is the construction of Whittingham Port project. When that construction happened, this project was said to have overseen a lot of local community needs and local problems. It caused a lot of soil erosion. The local fishermen were complaining that the fish stock is not there in the region anymore. Sea turtles are not present, and so on and so forth. There's a huge amount of environmental damage. That was one of the problems, and there was a huge amount of protest that happened because of that. The second example I want to showcase is how blue whales in off the coast of Sri Lanka has been endangered, and how the government had to take a standing to make sure that the blue whales are protected, because these are endangered species. And while I do understand that not all startup ecosystem does revolve around protecting the marine habitat, but we also need to realize that this also translates directly to economical profit because of the lack of tourism thereof that converges from this. So, while we'll discuss more about the solutions for these two problems and how MSP helps solving these. It's first important to understand what we actually mean by the word marine spatial planning. The marine spatial planning, again, as Arnab sir also rightly represented, it's basically one particular system, one particular dashboard, we can consider it, where all the different important information about the ecosystem is represented for all the stakeholders to see in a single platform. So as a port authority, you can see what kind of shipping noise is there in the region, what kind of sediment type is there in the region, what is the flow of the sediment, what kind of fish stock is there, what are the endangered species in the region, and so on and so forth. So one single platform where you have all the information available, and that's something that allows you to perform modeling and simulation. By modeling and simulation, what we mean is that taking a stock of if a port is constructed in a particular region, if there's an increase in the shipping traffic, how much amount of shipping noise will that contribute? And if there is an increase of shipping noise, how is that going to impact the local species in the region? What if we are performing a dredging in a particular, or if we are planning to perform an oil rig or anything, implanting an oil rig or something, we need to understand what kind of sediment is there to begin with, whether it's a clay sand or a sandy silt. Depending upon the different types of sediments, the different usages are different, and how much amount of strength will it provide to the platform. There is so many aspects that need to be considered, not just by the authorities that are developing the project, but also by multiple stakeholders, including the local communities, because even with the fishermen need to be aware of what kind of environment is going to get degraded and what is their alternative to that particular aspect. So that is our goal behind driving marine spatial planning as a unique platform that we have. Now, there are four strategic pillars of marine spatial planning. At the base, we have our data science and integration. All of this comes together again uh, as a tool, as a project. If we want to make it reachable, it needs to be a software as a solution that anyone and everyone can deploy and use. So, at the very core of it, it's all about data science integration, where we accumulate data from different sources like bathymetry, sediment type, AIS, using the satellite AIS data for the shipping traffic in the region, and so on and so forth. On top of that, we perform modeling and simulation. By that, what we mean, and that is what makes our effort of MSP based, modeling and simulation based MSP unique. We are not just representing what kind of shipping traffic is there in the region, because that definitely, although it adds value, what adds more value is what kind of noise is generated due to that shipping, because we want to estimate those kind of elements. Similarly, we are not just showcasing how much, what is the sea wave state. We are also looking at what is the impact of that sea wave state, and every single element, we are performing simulations on top of it, and we are deriving scientific results on top of it, and that result is what we are showcasing on that interface, and not just the aspect of not just the data in itself. And that's why the modeling and simulation and tooling comes below that. What drives that is essentially policy and regulatory framework. MRC in itself has done a lot of work in policy and regulatory aspect. I'll again showcase that a bit towards the conclusion, but we have contributed towards MEPC 76 and other such kind of reports have been published by MRC. And then the capacity building, because at the end of the day, all of this goes back to the local community, the port authorities, the governments, all different kinds of stakeholders. So a single tool where everyone can be aware of what's happening and educating them and taking their inputs to feed back into the tool, so that completes the cycle where the local community and the stakeholders are not left out of the whole tooling. And we at NDT, we keep on pressurizing on the fact that we are not providing just product and services. We are providing solutions that is that we drive. So, looking at the individual aspects, what do we really mean by what are the different components that MSP provides? Looking at sediment management, this basically includes inland waterways, and all of these are independent projects that we have already performed, and that's what I have listed here. Not something that we can. It's something that MRC has already done as part of the work that we have been doing. So inland waterways, having an aids to navigation, understanding. So in most of the shipping lanes, even though we have more than 147 inland waterways, a lot of it is unusable at this point of time because of lack of aids to navigation. So having an aids to navigation toward in the inland waterways, understanding what type of sediment is there in the region allows us to understand how much depth of the water is actually present for the ships to navigate, and what kind of ships can actually navigate in that particular channel. It can help devise policy framework. We have done so already for the sediment management in Brahmaputra Basin. Classifying the sediment, the tool will essentially represent what kind of sediment is there in the region, while taking into consideration the tropical waters. Indian subcontinent is unique in that tropical aspect, and we keep on mentioning that it's not a solution that is taken up from a different source might not work here, because being a tropical water basically means that the line at which the sound speed travels is the speed of sound, the sound speed minimum, what we call the SOFAR channel, that is very below 1500 meters is what we get for the Indian waters. And that basically means that the whole sound propagation channel is extremely different for tropical waters as compared to the polar regions. So that is something this tool takes into consideration. Bedload estimation, we use satellite based bedload estimation to understand what kind of bedload is there in the region. And we have also undertaken work of sediment classification in Ujjaini reservoir using a similar model. I believe my colleague will explain more on the sediment management aspect and like diving deep into that particular angle. The second component of MSP is the shipping noise and vibration. Basically, again, as I explained, not just about the which vessel it is, not just about the quantity of vessel, but how much noise that is derived from that vessel is what we are showcasing. And this we are doing it in a three-dimensional aspect. When we say three-dimensional, we can basically see the noise propagated not just on the ocean surface, but also below the water, how much noise is propagating from the noise generated by the ships. And all of this uses a lot of advanced technology. When we say something needs to be provided as a SaaS platform, a real-time estimation in itself is a huge amount of, it is a complicated task in itself. And we have designed and added our own neural network model for the same, where we, instead of calculating something, which is a mathematical model, which takes, if there are 1,000 ships and data points, that's going to take 1,000 times 1,000 n. What we do is use a neural network to perform the prediction, which is much more faster. So it gives us an exponential result. Um, so we have included a whole lot of AI to make the process faster and make it uh, much more easier and much more reachable to the local community. Um, Acoustic habitat mapping is one more element of the MSP. Again, understanding what kind of whales, which are the different regions where we can find the presence of blue whales, dolphins, and sea turtles. All of that is what we have aimed and what we have mapped. Now, while some may question that all of this the data will keep on changing, what we are doing is not just uh, accumulating data from a single point and showcasing. Again, we are estimating based upon the physical parameters, so based upon what kind of temperature and what kind of nutrient concentration uh, a particular species is present, we are basically mapping that based on the probability of the existence of those elements in the water, not just about where the sightings have been done, not just about where the whale sightings have been done, but based upon what food they consume, what kind of temperature do they reside in. So that basically captures not just the instance, or not that particular instant, but also the futuristic aspect of modeling where the whale will migrate if there is a difference in the temperature, or if the sea level rises, or if there is due to climate change there is an increase in temperature, what kind of migration pattern we can look at. All of that gets accumulated, all of that gets covered into this particular aspect. And the same goes for potential fishing zones as well. The other aspect again is urban flood mapping. Now, urban flooding is an increasing phenomenon that we are seeing, especially across the Brahmaputra region. We have done an urban flood mapping using the tooling for the Brahmaputra region, where we basically identify, uh, in case of an urban flood, what kind of an or what kind of population is gonna get affected, what amount of cropland is gonna get affected, so you can simulate and understand and be prepared before a flooding happens. And this also takes into consideration the amount, the elevation level, the drainage system in the region, and all the other different factors that contribute towards the flooding. So it's not just about how much rainfall is there, but also about what kind of runoff is happening of that particular water. And if it's near the river, then what kind of river discharge we are looking at, and so on. So it takes all of that into consideration, and we have modeled everything to add into our MSP toolkit. Moving forward from a maritime security perspective, it basically involves collision avoidance system and dark ship detection, both of them using a similar kind of an algorithm, but basically using the AIS data to first. So there are two elements we have taken into consideration. One is the satellite image, as well as the SAR image, as well as the AIS data. AIS data allows us to get information of what are the ships present if their AIS transponder is on. But there is also an aspect that if there is, again, as Arnab so rightly mentioned, the next 9/11 or 26/11 might not happen using land. So, and these kind of vessels, if they are parting in any kind of illegal activities, their AIS transponder is off. So we use our detection to identify the vessels and classify what kind of vessel it is, whether it's a small fishing vessel or it's a large vessel. And we match that along with the AIS data that we have, the satellite AIS data that we capture. And if there is anything wrong, if we see that there is a significant mismatch, we draw an alert out of it. Similar kind of an algorithm, but more from a collision avoidance system perspective, where we track the movement of the vessels, identify what kind of vessel path they are going to take, and identify whether the vessels are going to collide with each other or not, or what is the risk of collision for them. The one more element we have added is recently is the undersea cable mapping, where we have identified all the different the undersea cables in the region, because that is again an upcoming area of interest. So while we looked at a lot of different aspects of individual components of MSP, it's also important to understand what the different startup opportunities that are present in these particular for MSP in general, because after all, this webinar is based upon the startup opportunities for UDA. Now, in terms of sediment management, we're looking at there's an opportunity that the coastal infrastructure and port authorities require. They face a lot of cost in performing dredging and all those kind of activities, and this leads to a lot of risk of erosion and siltation problems. So a startup angle towards this will be basically looking at an AI/ML based sediment prediction platform for ports and coastal authorities. This can be subscription based, where the coastal erosion monitoring services can be used by these authorities to understand what kind of erosion are we looking at. Same goes for ship noise and vibration studies. Now, IMO is pushing towards a stricter global regulations. Every single country is kind of pushed towards mandating this directive, and this will basically mean that all the shipping companies have to adhere to this particular law. And the law essentially states that you need to reduce the amount of noise that is being generated. Now, to put that into policy perspective, the authorities need to have an understanding of what kind of noise are we actually having to begin with. There needs to be some kind of a baseline, and then we need to understand that if we reduce the number of ships, or if we change the route of that particular ship, what kind of noise level are we looking at. All of these, again, the authorities require a particular tool for that. So ship noise and vibration independently can also look at it from a startup angle perspective. And more from software as a platform element, this can be very much provided as a public API, which basically means any other tool, not just MRC's tool, but any other government tool can ingest data from MSP and display in their platforms or use in their platforms per se, or any startup project that is being done on top of that. Now, on-demand acoustic mapping services is again something that is there is a huge opportunity there, where basically a mapping of all the offshore wind, oil, gas, and all the blue economy projects can take into then that can be taken into consideration, and there can be data licensing that can be performed on top of it. This is important for both government as well as private companies. Um, Urban flood mapping, I don't think I need to explain too much on top of that. We already understand how flooding is a crucial element, and all the authorities, including municipalities and real estate developers, if we want to build a platform in a particular region, we want to understand what kind of urban flooding are we looking at, what is the risk of exposure there. So opportunities are massive in terms of urban flood mapping in itself as a startup opportunity. Dark ship detection from maritime security perspective, something that allows us to enforce and detect smuggling and IU fishing and other such kind of activities. We have a huge amount of bandwidth that can be filled up from a startup ecosystem perspective. And the same goes for collision avoidance system as well. As such, we have existing collision avoidance systems present, and that the same goes for even dark ship detection. But what we are looking at and what we have presented here is something unique in terms of both from an economically viable perspective as well as local indigenous solution to the problem that we have. Now, just to drive a bit more on the MSP aspect, we looked at the two problems that I had initially mentioned. One is the Whittingham Port project, where allegations were made for port construction that led to erosion and displacement of fishing communities. Now, having had an MSP tool which basically integrates all the sediment transport and simulations, and allowing it to predict the erosion and deposition, this basically would have given the planners a long-term understanding of what kind of stabilities will be there in the shoreline, and which kind of dredging and seawall design should have been used to minimize the erosion. Again, the idea is not to support one solution over the other, but try to move the economic viability of a project forward while making sure that the coastal community is not severely impacted. So it's finding a balance between the two. And this kind of what if scenario planning is something that is extremely required. Um, the second problem that we looked at is the problem with the ship strikes on blue whales. So where extreme amount of shipping had endangered the blue whale species off the coast of Sri Lanka. Now, I presented the case of Sri Lanka here, but this problem really is global, and including in the Indian subcontinent, where we have seen a lot of whales and dolphins washing ashore in the off the coast of Mumbai, and other places as well, for that matter. Um, and the reason why I chose Sri Lanka as a example here is because they have proven that they have performed a study, and they've basically proven that by just shifting the shipping lane by 15 nautical miles, they were able to reduce the collision risk by roughly 95% with these whales and dolphins. Now, this kind of a study, this kind of an example proves to us that this is something that has been done before and it is something possible. But we still need a technological intervention, in the sense we still need a tool that tells us that how much can we shift the shipping lane to, and where is the existing habitat of these blue whales and other endangered species for that matter, where those habitats persist. So we already have data enough on that, and this MSP tool will definitely allow in driving these kind of solutions forward, which are proven to be working. Um, Right. Shifting from the MSP, one other thing that I wanted to represent here is also the passive sonar simulation toolkit that we are working on. While MSP is something that integrates all the different components together, one of the component that we're also trying to add to into it is the element where, as a from a maritime security perspective, as a undersea vessel, being able to understand where you are the most vulnerable, which position you are the most vulnerable in, and in which position you can effectively deploy your submersible to gain the maximum amount of signal strength. That is something we are trying to devise right now. Um, what this essentially means is that, as I mentioned, tropical waters are very different, which means the SOFAR zone, the depth at which you get the least amount of transmission loss for signals is 1,500 meters, which is extremely deep for any submersible to be in without and withstand that kind of pressure. So then we need to identify that within the given region and within the given location, what is the best spot that we can obtain. And we have developed a tool on top of that where a user can select the sender and the receiver locations, and it tries to identify what the different angles that the signal will basically take. So there is a concept of what we call as a shadow zone, which basically means that if you identify a receiver is at a particular vicinity from you, we can identify where the signal will not reach much. I mean, the probability of detection is the least in which zone in the given region. And that is what this passive sonar simulation is basically all about. So concluding, again, we have done a lot of work on the MSP front. We have submitted papers on to the MEPC 76 and 81 as well. We have almost completed writing a handbook on marine spatial planning. We have done case studies on geoeconomics of UDA and IOR and the accounting frameworks for blue economy and UDA, all of which spans from our understanding of marine spatial planning and modeling and simulation based MSP that we are driving forward. So therefore, MRC and entity as an organization is not just ready for uh, what is about to come. We have already built on top of it. And more importantly, these solutions that we have mentioned is something definitely we feel will drive the UDA, not just UDA, but Indian subcontinent as a main leader in the underwater domain awareness moving forward.